Batteries consist of three main components: the anode, the cathode, and the electrolyte. The anode is a negatively charged electrode because of its extra electrons, and the cathode is a positively charged electrode because of the lack of electrons. The electrolyte is a semi-permeable, neutral area in between the anode and the cathode. It blocks the transfer of electrons, but allows the transfer of ions. This process is called an oxidation reaction. When the circuit is completed, the electrons follow the circuit and travel from the anode to the cathode, powering whatever they pass through. When the oxidation reaction occurs, the electrons follow the circuit to the cathode and the ions travel through the electrolyte to the cathode as well. The electrons will continue to follow the circuit until there are no more electrons to transfer. This is why a battery dies. In the case of a non-rechargeable battery, that is the end of its life. But rechargeable batteries are different. They can be recharged by reversing the oxidation reaction, so instead of the electrons flowing from the anode to the cathode, they flow from the cathode to the anode. The ions travel through the electrolyte, picking up the electrons at the anode, gaining a net negative charge. This is how batteries store power. Not all batteries are the same, but a large majority of them function using oxidation reaction. Lithium polymer or LiPo batteries operate under the same process. Because of their lightweight design, high power and cycle capacity, and variety of shapes and sizes, they have many practical uses. They are seen in RC vehicles, mobile devices, laptops, and many other applications. LiPos consist of multiple cells that are connected to form a larger battery pack. A major downside to LiPos is that they can be very dangerous. Because they use plastic as an outer casing, they can easily be punctured. When LiPo batteries are punctured or damaged, the liquid electrolyte can leak and short-circuit the battery. Instead of the electrolyte separating the anode and cathode, it allows them to complete a circuit. When a battery short-circuits, the electrons travel on an unintended path with very little resistance. This causes the battery to overheat and starts a process called thermal runaway. Thermal runaway is when a system releases a lot of heat, and that same discharged heat adds to the system, exponentially increasing the temperature. In the case of LiPos, the battery overheats to the point where it swells and the plastic casing cannot contain the pressure inside. The battery combusts and explodes, possibly causing catastrophic damage to its surroundings. Proper battery maintenance is very important to your safety and the safety of others around you. At any point in time, if you notice that your battery is swelling, getting excessively hot, or has any tears or punctures, dispose of it immediately. To properly dispose of damaged LiPo, you must fully discharge the battery using a LiPo discharger. If you do not have access to a discharger, you can always bring the battery to an electronic waste facility. Now that you understand the process of batteries on the molecular level, you can appreciate science every time you use your phone or other mobile device.